Hi, in this video, I will be showing you problem number 33 of chapter 13, section 2. The curves R1t equal to t square t cube and R2t equal to sine t sine 2t t intersect at the origin. Find their angle of intersection correct to the nearest degree. So first, the angle of intersection of the curves is nothing but the angle of intersection of the tangent vectors. So we have to first note that result. The angle of intersection of the curves is the angle between the tangent vectors at the intersecting point or at the point of intersection. It's given here in this problem, the point of intersection is at the origin. The two curves intersect at the origin. It's given in the problem. So we have to get the tangent vector. Tangent vectors are nothing but the first derivatives at the point t, and then we have to get the tangent derivative, the tangent vectors, the first derivative at the origin. So the tangent vectors of R1 and R2 vector functions are R1 prime t and R2 prime t. So R1 prime t is the derivative of the components of R of t. So you are given the vectors are t square and t cube, which are the components of R1. So if you do the derivative of each one of those, it is 1, 2t and 3t square. So that will be the tangent vector for the first one. So we have to evaluate this tangent vector at the point 0. So if you plug in 0 into this t, we get 1, 0, 0 as a tangent vector at the origin for the first curve. Same way we have to do the R2 prime at t, and then we have to replace that t with 0. R2 prime t is nothing but the derivatives of each component of R2. So R2 prime t is derivative of sine t, which is cosine t, derivative of sine 2t, which is 2 cosine 2t, and derivative of t, which is 1. So we got the derivatives of each component. Now we have to evaluate this at 0, which is the intersecting point. So it is cosine 0, 1, 2 cosine 2t, which is 2 times cosine 0, which is 2, then 1. So we got R1 prime at 0 and R2 prime at 0. Then if theta is the angle between the two tangent vectors, then we know that if given two vectors, we can get the angle between them through their cosine. And cosine of theta is R1 prime 0 dot R2 prime 0, the dot product between them, then divided by the length of the first tangent vector at 0 times the length of the second vector R2 prime 0. So the dot product is the dot product of these two, so which is multiplication of the corresponding components and adding. So 100 dot 121 divided by length of the first vector times length of the second vector, which will be, if you multiply the numerator, the dot product, 1 times 1, which is 1, and then 0 times 2, 0, 0 times 1, which is 0, so the numerator is just 1. The denominator, the lengths of each tangent vector, the first one is 1, the second one is radical 6. So cosine theta is given, so theta is cosine inverse. So we got the cosine theta, from which we can determine theta, which is cosine inverse of 1 over square root of 6, which is approximately 66 degrees from your calculator. So after this problem, I'll be showing, watch my other video, which is based on finding the indefinite integral of a vector function. Hope this video helps.